Hello guys, welcome in today's session. I am Professor Fayaz Kawadi from Department of Mechanical Engineering. In today's session, we are going to learn how to draw cam profile for flat face follower. This is our problem number 4, and how to draw the displacement diagram when acceleration and deceleration is not uniform, which is a new concept from unit number 4, cam and follower from theory of machine subject. I read the problem statement in front of you. Draw the cam profile operating a flat face follower with following data. Lift is given 45 mm. Cam lift the follower for 120 degree with simple harmonic motion followed by a dwell period of 30 degree. Then the follower moves lower down during 120 degree of cam rotation with uniform acceleration and deceleration, but the acceleration being half the deceleration. This is the new concept that we concentrating in today's session. The least radius of cam is 25 mm, which rotates at 300 rpm. Calculate the maximum velocity and acceleration during ascent or rise period. This problem is for 12 marks. Now the steps to solve the problem and marking scheme. To draw the displacement diagram, you will get 4 marks. With reference with displacement diagram, you have to draw the cam profile. This is for 4 marks. And by analytical method, you have to find out maximum velocity and acceleration during lift or a rise of the follower. Also, this is called as a forward or outstroke. This is for 4 marks. Now come to the first step to draw the displacement diagram. As we discussed in previous session, how to draw the displacement diagram when the follower moves with simple harmonic motion. In brief, I explained how to draw the displacement diagram, displacement curve in forward stroke. The forward stroke is given 120 degree. That 120 degree I will plot on x-axis by taking a suitable scale. And after that, I give the numbers to that all the points as 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, and last one is a 6 dash. At the same time, I will draw the on vertical axis the displacement which is given 45 mm. That 45 mm I will bisect and find out the center of the half circle. By taking the center, I will draw the half circle, and that half circle I will divide into number of equal parts, say 6. As I divide that horizontal line, that 120 degree into 6 number of equal parts. So one part will be of 30 degree, and I will give the numbers from bottom to top as the follower is moving from bottom to top as there is a lift or rise. So I will give the numbers here 1, 2, 3, 4, 5 and 6, and from all the points I will draw the horizontal line which is intersecting to the vertical line drawn from point 1 dash, 2 dash, 3 dash, 4 dash and 5 dash, so on. Now I will collect the intersection point as 1 double dash, 2 double dash, 3 double dash and so on. 1 double dash I am getting from the intersection of vertical line 1 dash and horizontal line 1. I got here 1 double dash. 2 double dash I am getting here from the intersection of 2 dash vertical line and horizontal line 2. 3 double dash I am getting here from the vertical line 3 dash and horizontal line 3. In this way, I will obtain all 6 points and I will join by the smooth curve. This is the method how to draw the displacement curve when the motion of the follower is simple harmonic. After that, for 30 degree, there is a dual pivot, so no displacement, so I draw the horizontal line here. Now the next thing, how to draw the displacement curve for a return stroke when the motion of the follower is uniform acceleration and retardation. As we discussed earlier, again I divide that horizontal line, which is a return stroke, into 6 number of equal parts, and I name it as a 7, 8, 9, 10, 11, and last one is a 12. Now the next thing is given, which is the important point for today's session is new concept is acceleration being half the deceleration, that is given in problem statement. So acceleration is equal to half the deceleration. Acceleration is denoted in next step is as A, and deceleration is denoted as D. So A is equal to half the D. So what I do the cross multiplication here. 2 acceleration is equal to 1 deceleration. So what is the meaning of this? In a return stroke, the 2 parts is given for acceleration and 1 part is given for deceleration. As I divide that length into 6 number of equal parts, so for getting the 6 number of equal parts, I multiply this equation by 2. And after multiplying, I am getting here 4 acceleration is equal to 2 deceleration. After multiplying this equation into 2, 2 multiplied by 2, 4 acceleration is equal to 2 deceleration. So 4 parts from that total 6 part is for acceleration and 2 parts for deceleration, as I divide into 6 number of equal parts. So total addition of this is 4 plus 2 is 6 number of equal parts. As you can see in this image. Now concentrate on this area only. This area, which is a return stroke. 4 parts, these 6, 7, 8 and 9. These 6 to 7 one part, 7 to 8 second part, 8 to 9 third part, and 9 to 10 fourth part. These 4 parts, as per this equation, these 4 parts I will give for acceleration, and these 2 parts I will give for deceleration. And from that I will draw the vertical line, and that vertical line I will divide again into 6 number of equal parts. This vertical line, not this mid line. In previous session, there is a uniform acceleration and retardation. So uniform length of outward slope is for acceleration and same length is for deceleration. So that mid line I divided into 6 number of equal parts, but that case is not happening in this situation. 4 parts I will divide it, I am giving for acceleration, and 2 parts I am giving for deceleration, and from that I will draw the vertical line, which is 10 number line. That 10 number line I will divide into again 6 number of equal parts. See in this image next, 6 number I will divide 6 number of equal parts and give the numbers as 7 dash, 8 dash, 9 dash, 10 dash, 11 dash, and last one is a 12 dash. As the follower is moving from top to bottom, there is a deceleration, there is moving downward. Follower is moving downward in return stroke. So I will give the number from top to bottom, 7 dash, 8 dash, 9 dash, 10 dash, 11 dash, and last one is a 12 dash. Also in that 4 parts I will give for acceleration and 2 parts I will give for deceleration. In horizontal line also, on horizontal line also I give 4 parts for acceleration and 2 parts for retardation. At the same time, that vertical line also I will give 4 parts for acceleration and 2 parts for deceleration. That is the new thing that you have to understand. Okay, and after that the same procedure I will join that from top left corner I will join 0, 7 dash, 0, 8 dash, 0, 9 dash, and last one is 0, 10 dash. and again 2 parts for declaration. So 10 dash and bottom right corner, that is again 0. I will join the line, and second line 11 dash from this corner. I am not joining from the midpoint 9 dash. This is the midpoint, and in previous session we join from that midpoint. Why? Because there is uniform acceleration and retardation, but in that case there is not uniform acceleration and retardation. Acceleration is being half the deceleration. So 4 parts. This will become now the acceleration. This part. So this area will become acceleration, and in this area you have to draw the curve in deceleration. Okay. Now, what is the procedure to obtain the intersection point? This 7 number line and this 7 dash. This will become here 7 double dash. This 8 vertical line, this inclined 8 dash, this will become 8 double dash. This 9 vertical line, this inclined 9 dash, this will become 9 double dash, and this will become 10 double dash. In this way, I will have to obtain all the points, and I will join these 7 double dash, 8 double dash, 9 double dash, 10 double dash, 11 double dash, and 12 double dash into by a smooth curve. Here you can understand, when acceleration is not uniform with the deceleration, acceleration is being half the deceleration, the curve is not uniform, or the curve is not symmetric. Okay, this is not symmetric curve. And why? Because acceleration is half the retardation. Okay, so this is the procedure to draw the displacement curve when acceleration is half the deceleration. This is the complete displacement diagram in front of you, but you have to understand this concept in this session. Acceleration half the retardation. Okay, now the next thing is to draw the cam profile. The procedure is same to draw the cam profile, only difference is that you will getting the point here 1a. You have to mark, again you divide that complete circle into 120 degree, 30 degree dual thread, and after that 120 degree return stroke, and you divide into equal number of parts and give the number 1 2 3 4 5 6 and so on. So what is the difference in previous session and this session? In case of flat face follower, you will mark that 1a, 2b, 3c, 4d, 5e, 6f from the displacement diagram, and from this point you will draw the flat faces. From point A, draw the flat face which is perpendicular to this 0 1 line. Through point B, draw the flat face which is perpendicular to that 0 2 line. Through point C, draw the perpendicular line which is perpendicular to 0 3 and so on. Okay, and now take precaution that don't draw the profile curve from point A, B, C, D. No, not like this. You have to draw the cam profile which is tangent to that horizontal line which you draw from point A, B, C, D, E, F respectively. Okay, draw the cam profile tangent to the flat face. Draw the cam profile tangent to the flat face, not from point A, B, C, D, E, F. This is wrong. You have to draw the cam profile tangent to flat face for every position, and after drawing the tangency you got that curve like this, and this is the final cam profile for flat face. Okay, now suppose in problem statement, for example, it is given like this: acceleration is 3 by 5 times the deceleration. Acceleration is 3 by 5 times the deceleration. What will you do in the examination? Acceleration is 3 by 5 times deceleration. So by cross multiplication, 5 acceleration is equal to 3 deceleration. So at that time, you will not divide that horizontal line into 6 number of equal parts. You have to divide that line into 8 number of equal parts. Why? Because 5 parts you will give for acceleration, 3 parts you will give for retardation, and addition of 5 plus 3 is 8. So you will divide that horizontal line, cam rotation line, into 8 number of equal parts like this. 1, 2, 3, 4, 5, 6, 7, 8. These 5 parts you will give for acceleration, and these 3 parts you will give for deceleration. Okay, so from this 5 number line you have to divide into 8 number of equal parts again, not this mid line, this where acceleration is ending, that line you have to divide into 8 number of equal parts, and you have to give the numbers from top to bottom as the follower is moving downward direction. Again, this 1, 2, 3, 4, 5, 6, 7, 8. In that also, this vertical line, 5 parts is for acceleration. This lift is 5 parts is for acceleration, and 3 parts is for deceleration. This horizontal line. Upper part is for upper rise is for acceleration, and lower 3 parts you will give for deceleration. And the same procedure you have to follow in next step, that join top left corner. From top left corner you have to join all the numbers 1, 2, 3, 4, and 5, and 3 parts for the retardation. From bottom right corner you have to join this first this corner to 5, this first part 6, second part 7, and last part is 8. So this area is for acceleration, and this area for retardation. And you know how to go get the intersection point and how to draw the curve. Again, in that case also, the curve is not mirror image of each other or not symmetric to each other, as there is no uniform acceleration and retardation. There is acceleration is 3 by 5 times the deceleration. Okay, now the third and last thing, to find the maximum velocity and acceleration during ascent period by analytical method. Okay, RPM is given 300. So this RPM I will convert into radian per second. So formula for this is omega is equal to 2 pi n upon 60. So after calculating, I will get the omega as 31.4159 radian per second. The maximum velocity now we have to find out during lift or during a rise. So formula for, as we discussed in previous session, that this table you have to remember. Okay, in forward stroke simple harmonic motion is given. Okay, so we have to find out the velocity in forward stroke during simple harmonic motion of the follower. The formula for this, pi s omega divided by 2 theta outward. Okay, so pi s omega divided by 2 theta outward. This pi into this s which is given 25. This s I will convert into in meter. 25 into 10 raised to minus 3 divided by 2 into this theta which is given in degree. You have to convert into radian by multiplying pi by 180. Pi by 180. So after calculating, this omega is given here. Omega value of omega is 31.4159. After calculating the velocity during outward slope, I am getting here 0.589 meter per second. And the maximum acceleration of the follower, maximum acceleration of the follower. This is the acceleration, and during outward stroke we have to find out. So acceleration during outward stroke when the motion of the follower is simple harmonic motion again. So formula for this is this, plus minus pi square s omega square divided by theta 2 into theta outward. So, or you can say pi omega divided by theta outward bracket square into s by 2. Okay, the same formula I'm using here, plus minus pi omega theta outward bracket square into s by 2. After putting all the values, I am getting acceleration during outward stroke when follow motion is simple harmonic plus minus 27.7582 meter per second square. So in this way you have to solve the numerical in examination also for 12 marks. Okay, so at the end of the session, the students can understand the procedure of drawing cam profile for flat face follower when the acceleration is half the retardation, and also you can be able to calculate the velocity and acceleration for given type of follower motion. Thank you for watching this video.